Today we'll be looking into how to build a touchless angular double motor control for Leap Motion C# mobile base. This project is to use Leap Motion to control a mobile base, making it a touchless mobile base. And this is how it will look like. Here is the X position of the hand. As you can see, here is the Z position of the hand from forward to backwards. This is the magnitude from the origin of the hand, and here is the angular value of the hand as it rotates clockwise or anti-clockwise from 0 to 90. This is the frames per second, and this is the left motor power in 100%, up to 100%, and the right motor up to 100%. This is the number of hands that the Leap Motion device detects. So let's move into the code and see what can we find from here. Here are all labels, and here are all text boxes. There's only one picture box to display the output of the Leap Motion sensor. So in Form 1, where the code is, if you do not know how to set up a project for Leap Motion, I'll recommend you the setting up of a Windows Forms or WPF project in the Leap Motion developer website. Alright, without further ado, let's move into the code itself. Here is standard. Okay, once we have reached here, here is the hand count. So if the hand count from the Leap Motion is more or equals to 1, and the hand that is detected is more than the hand that's detected is closed, or the grab strength is equals to 1, that's where we will put in the pump position X and pump position Z into F hand X and F hand Z. Next, we'll be calculating the magnitude of the hand from the origin using this method of C equals to square root of A square plus B square. And here's the code. After that, we'll be checking for the magnitude, which is here. If the magnitude is less than 40, or the magnitude is more than 240, this is where we do a check. If the hand is less than 40 of the origin, or at the origin itself, it has a possibility of entering into any of the 8 segments without us having a choice, because it is very sensitive at the center. So in order to reduce the error, or to avoid the error, we will put a limitation of a radius of 40 all the way to a radius of 240. And within all these values, internal values, it will all be 0, and after all these external values, it will be 0. If not, the magnitude will be minus 40 times divided by 200 times 100%. 200 is because of the units here. These are the difference between 240 and 40 is 200 units. So we dividing them by 200 units and multiplying them by 100%. If not, the rest will be first hand X equals 0, F hand X equals 0, and magnitude equals to 0. Next, the reason why I'll be using all these things is so I can calculate the angle of the hand at any position. As we go on to calculating the angle of the hand from the origin, this is the method that I use, which is to put the motor at 90. 90% is the 100%, or the maximum that you can get out of this graph. It is just an example. So the left motor and the right motor will be at 90, the left motor at 45, 90 and 45 at this angle, 45 and 0, 0 and minus 45, and so on. The reason I chose this method is so as to maintain the speed of the unit as it continues to be at these 2 segments, so that it will be effective. And once it reaches these two segments and below, it will slow down both motors so that it will focus on realigning back the awkward angle. So in order to check out this angle, we'll be using tangent of z over x and multiplying it by 180 because it's in radians, and converting it back to degree mode. So if the angle is more than 45, which is here, because the f and x is more than 0, f and x is f hence z is more than less than or equal to 0, is this segment. So if the angle is more than 45, left motor will be 90 and the right motor will remain at its own angle. It can change from 90 to 45. And as you continue to see, if the angle is less than 45, which is this segment, the left motor will be 45 plus angle, and the right motor equals to angle itself. And as we continue to scroll down from this segment, you'll see that I use the absolute because the value in this segment would be a negative. After using that, I'll be using the tangent and tangent z and x again, doing the same thing. And if the angle is more than or equals to 45, which is this angle, this segment here, the left motor equals to the angle and the right motor equals to 90 for constantly. So this will be repeated 8 times. Once, twice, thrice, 4 times, 5 times, 6 times, 7 times, 8 times. Over here. 1, 2, 3, 4, 5, 6, 7, 8. Right here. And after all these calculations are done, we'll move on to the left motor and right motor. In order for the left motor and right motor to have these values and also be adjustable to the different magnitudes, so that if the hand is placed closer to the edge here, the motor will move faster. If the hand is placed closer to the center, it will move slower. For that to happen, we'll be using the left motor multiplied by the magnitude and dividing everything by 90. After that, if there is no hands that is detected, both of the motors will come to a complete stop. And this is just to output the remaining values. You can change this to your output values to any serial port and any serial monitor that you are using. And that is it. I hope you enjoy the video.